Now that you are familiar with the basic concepts of programming, Java and Eclipse, it's time to delve into object-oriented programming for real in this chapter. Let's kick off with the outline. We will start by thoroughly explaining the difference between classes and objects, two key concepts in object-oriented programming. We will then zoom into both variables and methods, which together make up a class definition. The chapter will conclude by discussing some interesting Java SE built-in classes which may come in handy as you start to develop your first Java applications. A class is a blueprint or template of object characteristics. Vice versa, an object is an instance of a class. Let's illustrate this with a brief example. Consider a class instructor. This class describes all the characteristics of an instructor. Think about the name, birth date, address, courses taught, etc. Bart is an object. He is an instance of the class instructor with a particular name, address, birth date, courses taught, etc. Likewise, Seppa is also an object. He is also an instance of the class instructor with a particular name, address, birth date, courses taught, etc. Objects are characterized by both data and behavior. The data is represented by means of variables. In our instructor example, you can think about name, address, birth date as examples of variables. The behavior is represented by means of methods. In our instructor example, you can think of a method age, which calculates the age of an instructor by subtracting the birth date from the current date. Another example of a method could be number of courses, which calculates how many courses an instructor teaches. Can you think of some variables and methods that could be useful for a class student? A key principle of object-oriented programming is information hiding, which states that an object's variables can only be accessed by means of its methods. We will discuss more about this in a later chapter. Java is a pure object-oriented programming language. There are no standalone constants, variables, or functions. Since Java version 5, also the primitive data types such as boolean, byte, int, double, etc. can be represented as objects using the concept of auto-boxing. In other words, each primitive data type has a corresponding wrapper class such that a boolean, byte, integer, double, etc. can also be treated as an object. A Java class is defined as follows: the keyword class followed by the class name. You can choose any class name you want, provided it starts with a letter, underscore character, or $sign. To facilitate the understanding of your code, it is recommended to use upper camel case to format your class names. Also make sure to use meaningful names such as book, student, instructor, etc. The body of a class is surrounded by curly brackets. Within this body, you then define the variables and methods. It is recommended to first start with the variable definitions, followed by the method definitions, although this is not strictly required. Here you can see an example of a student class. It has both variables and methods. Each variable has a corresponding data type. The ID variable is an identifier of type integer. The data type of the first name and last name variables is string. Birthday, birth month, and birth year are represented as integers. The class also has three methods. The method isBirthday returns true if it's the student's birthday today. The method giveWarning issues a warning in case the student needs to study harder. The method number of friends returns the number of friends a student has. Here you can see the Java representation of our student class. First, we start with the variables. You can see all our variables defined with their corresponding data types. Each variable definition starts with a data type, followed by one or more variable names, followed by a semicolon to indicate the end of the statement. In case multiple variables have the same data type, such as birth year, birth month, birthday, we can use a comma as a shorthand notation. Remember, as discussed in Chapter 2, it is recommended to format variables in lower camel case. The second part of the class describes the methods. Each method starts with a return type, the name of the method, and a number of arguments the method takes as inputs. Just as with variables, it is recommended to format method names using lower camel case. The implementation of the method is given in its body, which is again enclosed within curly brackets. What is the return type of the isBirthday method? Indeed, it's Boolean, representing whether today is a student's birthday or not. Note that the return keyword is used to indicate what the method returns. What is the input argument for the giveWarning method? Indeed, it's a variable isFinalWarning, which is Boolean, so either true or false, indicating if a warning should be issued. What is the return type of the giveWarning method? Indeed, it's void, which indicates that the method does not return anything. A method can take an arbitrary number of arguments, separated by commas, and for each argument, the type needs to be specified. Even when the method has no arguments, the parentheses need to be added to the method names, as illustrated with the isBirthday and number of friends methods. Let's now create our first object. Remember, an object is an instance of a class. When considering instructors, are board and SEPA classes or objects? Indeed, they are both objects of the class instructor. Objects can be created using the keyword new. You can see this illustrated here. This statement creates a new object, my first student. In other words, my first student is an instance of the class student. You can create as many objects you like, each with their own characteristics. Here you can see this illustrated. We created two student objects, my first student and my second student, using the keyword new. Let's now add a new method, main, to our student class definition. This method is defined as public static void main string args. Don't worry what public and static means. We will explain this later. The name of the method is main, and its argument is an array of strings referred to as args. Remember that void indicates that the method does not return anything. This is a special method, as the main method is always the method that is executed first. So if you define a student class in Eclipse and run it, then Eclipse will always execute the main method first. In other words, the main method is the entry point of program or class execution. The main method starts by defining two student objects, first student and second student. It then sets the ID and first name variables for both students. Note the use of the dot operator to access the student object's variables. First student.id equals 1 and first student.firstname equals Mark. The statement system.out.println is then used to print the first name of the second student on the console. We will explain more about the meaning of this statement in what follows. Let's now provide some more detail of how variables can be defined in a class. In what follows, we will discuss instance variables, class variables, final variables, and variable scope. An instance variable is a variable which belongs to an object. It is also referred to as a member variable or field of a class. Each object keeps a separate copy of its instance variables. Instance variables are assigned default values when they are defined. Let's illustrate this with an example. Here you can see a class book. What do you think are the instance variables of this class? They are title, which is a string initialized to unknown title, authors, which is an array of strings initialized to anonymous, year released, and copy sold, which are both integers initialized to 2014 and 0 respectively. The main method creates two book objects using the keyword new, remember. For both books, the title and authors are set. Title and authors are instance variables since they have a different value for each book. This also applies to the year released and copy sold variables. A class variable is a variable which is shared between all objects belonging to the class. It is also referred to as a static variable. Class variables can be accessed either directly through the class or through an object. Let's illustrate this with an example. Here you can see our book class revisited. We now introduce the class variable max amount of pages, which is initialized to 500. Class variables are defined by means of the keyword static, as you can see. The max amount of pages variable has now the same value, 500, for every book object that you create. In the main method, we create a new book object, superLargeBook. Its title variable is set to superLargeBoringBook. The next statements print the title, authors, year released, and number of pages to the console. The final two statements print the maximum amount of pages, first accessed through the superLargeBook object, and then through the class book itself. Final variables are variables which are initialized only once. They can be initialized either when they are defined or later in one of the class methods. Once a value has been assigned to a final variable, it cannot be modified any longer. You can see this illustrated here. The title variable is now defined as a final variable initialized to unknown title. What do you think Eclipse will do when you run this class? Indeed, it will refuse to compile this code since you cannot give the title variable, which was defined as final, a new value. Here you can see another example of using final variables. You can see two variables, max amount of pages and minimum amount of pages. Both are defined as final variables. Are they instance or class variables, you think? They are class variables because they both are defined using the static keyword. So in other words, both are final class variables. Essentially, they are both constants set to 500 and 50 respectively and shared by all objects of the book class. The recommended naming convention for constants is capitalized underscore separated form, as you can see. In the main method, you can see that both final variables can be accessed directly through the book class, since they are both class variables. Also, objects can be defined as final. You can see this illustrated here. The superLargeBook object is created as final. It means this object is created or initialized only once. It does not mean that we cannot change its variables. So, it's perfectly okay to change the number of copies sold as indicated. However, the last statement, superlarge book equals new book, will generate an error since the superlarge book object has already been created and was defined as final. Variable scope is another important concept. It refers to the context in which the variable is known. The following levels of scope can be defined. A local variable is a variable which is declared inside the method or code block. A parameter variable is a variable which is declared as a method argument or loop variable. An instance variable is a variable which is declared in the class definition. The levels of scope are ordered. Here you can see three examples of variables. Instance var, which represents an instance variable, param var, which is a parameter variable, and local var a, which is a local variable. Instance variables can be accessed by all methods in the class, as you can see. Parameter variables can only be accessed by the method itself, but not by other methods, as also illustrated. Hence, we can use the same name for parameter variables in different methods, as was done here. Local variables can only be accessed locally within their method or code block. Hence, we cannot access local var a in method make b. Let's see whether you get this. What will happen if you execute this code snippet in Eclipse? It will give you an error. Why? The variable a is a local variable defined in our method makeA. Hence, it's only accessible within the method body and not outside. So when the readA method is called, the variable a is unknown and an error will be generated. Here you can see another example. What value will be printed out here? 5 or 10? Indeed, it will be 10. When running this, Java will first look for a local variable called a. If it can find this, it will print out its value. If not, it will go one level up and look for an instance or class variable with the name a. Since a was defined locally, it will print out its local value, which is 10. This concept is referred to as variable shadowing, whereby the local variable overshadows the higher level ones. Mind though, that it's highly recommended to use clear and unambiguous names for your variables. Let's now get a closer look at the behavior of a class, or in other words, its methods. Just as with variables, we will first discuss instance and class methods. This will be followed by constructors and the main method, which we already briefly introduced. We will also zoom into method argument passing. Similar to instance variables, an instance method is a method that is accessible only through an initialized object. It is also referred to as a member method. Let's work out an example. Here you can see an example of a class dog. It has one instance variable isSitting, which is of type Boolean, and 4 instance methods getBarkSound, isSitting, sit, and stat. Remember that a method always returns a type or void if it doesn't return anything. A method returning something should always include the keyword return in its body. In the main method, a new dog object, myDog, is created. We then call the instance method getBarkSound and print the result to the console. A method can take one or more input arguments. Here, you can see some examples of method declarations. The giveCookie method takes a cookie object as its input argument. The chaseDog method takes a dog object as its input argument. The lickPerson method has 2 input arguments, a person object and number of licks, which is an integer variable. The giveNicknames method takes an array of strings as its input argument. We can then define a new array, new names, with the strings Puppers and Droopy and call the giveNicknames method of the myDog object with the new names array as the input argument. varArgs is a special construct, allowing a variable number of input arguments. You can see this illustrated here. The 3 dots after string indicate an arbitrary number of strings. The nicknames variable can then be treated as an array of strings in the method body. In the latter, you see the statement nicknames.length to represent the number of names given. The method can then be called with a variable number of strings, such as Puppers and Droopy, or Puppers, Droopy, Tissues, and Clifford, or no strings at all, as illustrated by the last statement. When using varArgs, it is important to note that this should always be the last method argument, and only one varArgs argument can be defined for a method. Just as with class variables, a class method is shared between all objects belonging to the class. It is also referred to as a static method. A class method doesn't need an object to be used and can be directly invoked on the class. Let's continue with our pets example. Here you see a cat class. It has a class method preferredFood, which returns the string fish. Note the static keyword, which is used to indicate that it is a class method. In the main method, a new object, myCat, is created. As illustrated, the class method preferredFood can be invoked on either the myCat object or directly on the cat class, which is the preferred way. Let's now take a look at this code example. What do you think will happen if we run this in Eclipse? It will generate an error, as we are modifying the instance variable name in the class method changeName. Put differently, class methods are not able to access or modify instance variables. Here you can see a better alternative. We have defined a class variable preferredFood, which is initialized to fish. We also added a getter and setter class method. The class method getPreferredFood will return the value of the preferredFood variable. The class method setPreferredFood will allow to set a new value for the preferredFood class variable. The idea of using getter and setter methods for accessing variables will be referred to as encapsulation or information hiding, as we will discuss later. Constructor methods are a special type of class methods used to construct or initialize objects of a specific class. A constructor is defined in the same way as an instance method, with the following 2 differences. A constructor method has the same name as the class and it has no return type, not even void. There is no need to explicitly define a constructor for a class, as Java will automatically assume a blank constructor when you do not define one. A constructor is invoked each time you create or instantiate a new object using the keyword new. They can be helpful to initialize default values for the object that is being created. Let's work out an example. Here you can see our earlier book class. You can see this class has 3 constructors, each taking a different number of arguments. The final static variable, default here, is acting as a constant and used as a default initializing value in the first constructor. The 2 final instance variables, title and release here, need to be initialized by every constructor. The non-final variable copy sold is initialized in the 3rd constructor. Which constructor is invoked depends upon how many parameters are passed along when a new book is created. You can see this illustrated here. In case only the string Java programming is passed along, the first constructor will be used. In case the string Java programming together with the integer 2015 is passed along, the second constructor will be used. Finally, in case the string Java programming and the integers 2015 and 5000 are passed along, the third constructor will be used. If you look carefully at the constructors, you might see that some of the code is duplicated, such as title equals T and release year equals R. Can't we not make this more concise? Yes, we can, because a constructor can also call another constructor, as you can see illustrated here. Let's look at the first constructor. Using the keyword this, we call the third constructor with the three input arguments t, default year, and 0. Likewise, the second constructor also calls the third constructor with the input arguments t, r, and 0. We will provide more detail about the keyword this in a later chapter. We already explained the functioning of the main method a few times. Remember, it's the entry point to execute your program. It is always defined as public static void main string args. Do you think the main method is an instance or class method? It's a class method since it is defined using the keyword static. The keyword public is an access modifier indicating that the method is publicly accessible. We will explain more about access modifiers in a later chapter. The main method does not return anything, as indicated by the keyword void. It also takes only one argument, which is an array of strings. Ideally, a main method is not put into a class definition relating to a real-world concept such as book, student, etc., but in a controller class. Here you can see this illustrated. Our book class represents a business or real-world concept. We also defined a controller class program with a main method. This class is used to start the program. The main method creates two book objects, calls the sell method for the first book object, and then prints the number of copies sold of the first book and title of the second book to the console. To conclude the discussion about methods, let's zoom into method argument passing. We have already discussed that a method can have one or more input arguments. The question now is how these arguments are passed when the method is called. Primitive data types, such as boolean, int, double, etc., are passed by value. Non-primitive data types are passed by value of memory address of the object. This may sound a bit complex right now, so let's provide some examples. Here you can see our first example. Let's discuss it into more detail. The class test has one instance variable a, which is of type integer and initialized to 4. The class method increaseInt takes one input variable, referred to as an int, and increases it with 1. The main method creates a new test object t. It then prints out the value of its instance variable a. What do you think the result will be? It will be 4. We now call the class method increaseInt with t.a as its input variable. The value 4 will now be passed to the method increaseInt, where it will be increased with 1 unit and thus become 5. Since only the value is passed, it will not be returned to the caller, so nothing changes to the value of t.a. Hence, if you print it again to the console, you will notice that the value is still 4. Here you can see the output of our program. What happens now if we work with non-primitive data types? Let's work out an example. We defined another class test. Let's find out what happens in this example. We have an instance variable array, which is initialized to an array with three integers, 1, 2, and 3. We then have a class or static method, increaseFirstInt, which takes one input parameter, an int array, which is an array of integers. This method then increases the first value of the array. Remember, this is the value at position 0. In our main method, we first create a test object t and print the value of the array to the console. Obviously, the first value will be 1. We now call the method increaseFirstInt with t.array as its input variable. What happens now? Since t.array is a non-primitive data type, its memory address will be passed to the method increaseFirstInt. Let's say the memory address is 10. The method increaseFirstInt then increases the first element of the array stored at the memory address 10. If we then print out the value of t.array 0 in our main method, we will see that it is now 2 as anticipated. Here you can see the output once more. Let's discuss one more example. We again have our class test with an instance variable array initialized to an array of three integers, 1, 2, and 3. We have two static or class methods. The method increaseFirstInt takes an array of integers as its input argument and increases the value of the first element with 1 unit. The method changeInt also takes an array of integers as its input argument and then assigns a newly created array to it with the integers 100, 200, and 300. Let's now zoom into the main method. We first create a test object t and print out the value at array position 0. Obviously, this is 1. We then call the method increaseFirstInt with t.array as its input argument. Remember, this means the memory address of t.array is passed to the method increaseFirstInt. In this method, the first element of the array at the given memory address is increased with 1 unit. If we then print out the value of the array at position 0 in the main method, you will see that it indeed has increased to 2. Finally, we also call the method changeIntArray with t.array as its input argument. This method creates a new array stored at a new and thus other memory address and assigns it to an int array. If we then again print out the first element of t.array in the main method, you can see that it remained unchanged to 2. Here you can see the output. To make sure you fully understand this, let's explain it once more. So remember, we first create an object t. Don't think of t as containing all information and behavior stored in the test object, but as a piece of paper holding an address in memory, say memory address 23. What happens now when we call the method increaseFirstInt with t.array as its input parameter? You can think of t.array as a piece of paper with the memory address where the array values are stored. So here you can see how we navigate now. When resolving t.array, Java first goes to the memory address for t, which is 23. Then retrieves the array variable, which is another memory address where the data is stored. So when you write t.array 0, you are traversing two memory addresses to find the actual value 1 stored at memory address 25 as illustrated. The memory address of t.array, or in other words 25, is then passed by value to the method increaseFirstInt. Put differently, the method takes a copy of the address. when the method executes an int array 0 plus plus, it will increase element 0 of the array starting at memory address 25 with 1 unit. If we then print out this very value in the main method, we will have 2, obviously. Let's now see what happens when we call the method changeIntArray. As previously, we pass the value of memory address 25 to this method, which is there known as the variable in int array. However, this address is then overwritten by creating a new integer array with values 100, 200, and 300 stored at, let's say, memory address 29. If we then print out the value of t.array0 in the main method, it will still refer to memory address 25, or in other words, print out the value 2. We can now finish our discussion on classes, objects, variables, and methods. Our class skeleton definition thus looks as represented here. It starts with the final class variable definitions, followed by the class variable definitions, final instance variable definitions, instance variable definitions, constructor method definitions, class method definitions, and an optional main method definition. As we discussed in chapter 2, there are multiple editions of Java. The most popular and widely used is Java SE, or Java Standard Edition. This edition comes with class libraries or packages containing a number of built-in classes with predefined functionality, which are very handy to reuse as you are building your Java applications. As said, the classes are grouped into packages, whereby a package is a grouping of classes providing a specific type of functionality. Here, you can see some popular Java packages listed. The java.lang package contains the core classes related to the Java language. It is imported by default. In other words, every Java class can make use of the classes defined in the java.lang package without having to explicitly import the package. The java.io and java.nio package provide classes to deal with input and output, such as reading and writing files. We'll discuss them into more detail in a later chapter. The java.mat package provides a set of mathematical functions. The java.net, java.rmi, org.omg.corba packages provide functionality to allow for web-based communication. The java.awt and javax.swing package allow to build graphical user interface or GUI applications, as we will discuss later. The java.util package contains a large number of classes to deal with various data structures. Let's give some examples. Here you can see an example of using the mat class from the java.lang package. Remember, this package does not need to be explicitly imported. Our main method defines two double variables and then uses the max, min, sqrt, and pow methods of the mat class to perform some mathematical calculations. Another useful class of the java.lang package is a string builder class. A string object in Java is an immutable sequence of characters. Put differently, a string object cannot be changed, and every time you modify it, a new string object is created. This gives a lot of overhead when you are dealing with strings that are frequently modified. On the contrary, a string builder object represents a mutable sequence of characters which can thus be modified without having to create a new object each time. You can see this illustrated in this code, where both a string and string builder object are compared. First, we create an empty string object. We then record the time in milliseconds by creating a start time 1 object. This is followed by a for loop. We haven't discussed loops yet, but this loop essentially appends the letter A 100,000 times to the string such that we end up with a string of 100,000 A's. We then record the end time by creating an end time 1 object. We now do the same thing with a string builder object. We can then compare the time it took to do both operations. Here you can see the output I get on my laptop. When working with strings, it took us almost 4 seconds, whereas the string builder object worked a lot faster. Hence, when you're working with strings that need to be modified, it is recommended to use the string builder class. To conclude, let's discuss some interesting classes from the java.util package. A large part of the classes contained in the java.util package belong to the Java Collections framework. These are classes which can provide a better alternative for arrays. One example is the hashSet class, which allows to work with sets. Remember, a set is an unordered collection of objects with no duplicates. This example shows how to define a set of strings using the hashSet class. Note that we first explicitly import the class using the statement import java.util-hashset. The methods add and remove allow to add and remove elements from the set. You can see that the string A is added twice, but since a set has no duplicates, it only appears once when we print the set. It would be pretty daunting if you would have to implement this using arrays as illustrated in our book. Here you can see some other collection classes from the java.util package illustrated. Contrary to an array list is an object for which the size does not need to be specified upon creation. In our collections tester class, you can see an array list object created containing string objects. You can also note the hashmap class. This provides a simple data structure that associates values or objects with a key, so it essentially maps keys to values. You can think of this as a dictionary. The word being looked up is the key and the description is the value. In our case, the key is of integer data type and the value of string data type. All these collection classes will be very handy, as we will discuss in later chapters. Good news! We are finally finished with this chapter. Remember, we discussed how to create both classes and objects in Java, how to define variables and methods, and we also briefly reviewed some important built-in classes providing interesting functionality. You still have quite a bit of ground to cover to become proficient in Java programming, but you're on the right track. So let's take a well-deserved break first and then continue with the next chapter.